Okay, I would say let's kick it off. It's 1 minute after 4. Welcome, everybody. It's a pleasure to introduce you to today's webinar. It's all about AI agents, and yeah, we have prepared lots of interesting insights, some interactive elements, some live demonstrations, some customer use cases that we are allowed to share, and we also a Q&A session, of course, at the end. So I'm really much looking forward for this webinar into your questions and also thoughts. And I have the honor today to be with my colleague, with Ram. And yeah, Ram, maybe you can say a few words to yourself, where you are and what you're doing at Sonera.
Thanks, Moritz. Also happy to co-host this webinar along with you. Hi, everyone. I'm Ram. I'm currently leading our AI activities at the moment. I'm originally from India. I came to Germany for a master's in computational mechanics at the University of Stuttgart. Have been in awe of AI across different algorithms for the last 5 years and working a lot with them. I'm super happy to be here and present some of the exciting things we have been doing for the last couple of weeks and months. So looking also forward to your questions.
Amazing. Thanks, Ram. And maybe also a few words to my side. I'm Moritz, one of the managing directors and founder of Sonera, and I had the opportunity to really deep dive into this topic since roughly 1 year now. And really looking forward to share our learnings, our findings that we have learned across this journey so far. So yeah, let's kick it off. I would like to start actually with the first interactive question to you guys here. And it is all about actually how much of your work day in R&D are you currently spending in, let's say, so not so productive meetings? So this could be, for example, fitting in meetings with colleagues or writing emails, summaries, maybe waiting for results from your colleagues from simulation department, or just like, I don't know, reading newspapers or stuff. So I would like to start a little like poll. So I hope you should kind of see this little pop-up now here that you can answer. And I'm really interested in how productive you are in your company and how efficient your engineering day-to-day work is. Answers are popping in. With roughly the half of the answers are here already. Okay, we wait a couple of more seconds. It's over 50 answers already. And maybe a couple of more. If now, 3, 2, 1. Let me share the results with you. It's actually the most of you, roughly like over half actually, are 1 to 2 hours actually per day. So this would be roughly 25 to 30% of the workday, 1/3. There is a slight, well, what is it like? Comparison between less than 1 hour, so super productive. 8 people actually are super productive in here, less than 1 hour. Also, 6 people more than 4 hours. That's interesting. And yeah, so a big picture, but I guess the majority is around maybe 2 to 3 hours. And that's interesting. So we also kind of asked our customers the same question. And I would like to like share some insights here. So the answer that we got actually was that roughly 50% of the time our customers are like sitting in productivity mode, so either doing CAD designs or simulations. And there's roughly 1/3 aligning, sitting in meetings. And also some of you have really been honest and doing like 13% of socializing and coffee drinking. So this is kind of interesting. And I guess this is just human, right? As humans, we love to actually interact, socialize. So this is something which is typically normal. And I think if we're looking into engineering efficiency and also we can automate this, this is definitely something where we can have potential to be, let's say, more efficient. But then actually, it's not only us individuals. So we are working in teams, for example, a simulation department or even like different departments in different silos. They are working together we call it like a product development process. So usually if you get like a task, for example, from your management, we want to build this and this new product. The requirements are this and this. It drops down to maybe the first department, design department, for example. Here, the tasks get distributed then back to maybe detailed design, to simulation. Then you're sitting together in a meeting and arguing about the best design or whether it's feasible or not. And it continues and it continues. So this is more like a long time process. And we call this like the time to market that we are looking in here. And just to share some insights here, I guess if you look into, for example, the new OEMs, like the Chinese OEMs especially, they have time to market cycles of roughly 2 years at the moment, where we are here in Germany, actually, we take longer than this, unfortunately. So there's room for improvement. And yeah, we definitely see some potential here. And it's not only about like inefficiencies in processes and individual levels, we also have some inefficiencies that we can work on when it comes to organizational structures. So whenever there's an engineering team, somebody needs to communicate, steer, make rules, and actually orchestrate it. So we're talking about management structures. And if you look into a typical organigram from a company, we definitely see that some of the people actually are required to actually align and to focus the engineering teams. And also this kind of like is something where we can optimize efficiencies. So lots of potential for us engineers to improve, to get better, to get faster, and to save time. And I would like to maybe start today's webinar with a short motivation about why we actually are here and we would like to talk about agents. So I'm not sure actually who of you have seen the movie Iron Man from Marvel. I guess it's a nice movie. And when I saw it the first time, it totally hit me. So Tony Stark, this is like the superhero in this movie. He has kind of like an system, an AI system he calls Jarvis, and he can interact with this system just like with a classical co-pilot or something. So you ask, for example, what material should I use for my next Superman suit? Or how much range can I put out of my machines in here if I need to have this new energy bill here? So it's like an interactive colleague, actually. And this is kind of the vision that we are trying to develop. And so far, actually, we always knew there was rule-based automation, so low-code automation, as you knew what we're doing. But then it was always the question, how do we come from automation, from our software stack, from our really like heavy loaded engineering tools and activities to a more like Jarvis system? And actually last year, there was like a technology popping out, which well, we thought, well, maybe this technology really brings us a long way down the path to Jarvis. And there, I guess, Ram, we would like to know a little bit more about what this technology is about, right?
Yeah, absolutely. So, like Moritz mentioned, we were always thinking, what is the most fundamental unit of this future going to look like? And if you go to the next slide, Moritz, we figured out when LLMs came, they brought a lot of capabilities along with them. So we define a scenario agent to be a combination of three things. So at the core, it's basically large language models. And when you give an orchestration layer to these large language models, for example, a profile, a specific job orientation, if you equip them with memory, and also if you give them some planning capabilities, they are already much better and they're not just a large language model. But what sets a scenario agent apart is the access to real rule-based engineering workflows, which are basically scenario workflows. And what happens is if you ask one agent an engineering question, they can think through their profile, they can use scenario workflows and come back with a factual answer. And then we thought, what if we take multiple agents like this and put them together? And that's when we got the multi-agent systems. So these are basically mimicking R&D organizations as they are today. So Moritz showed us how engineering organizations work today, and we wanted to see if agents can also do this. What happens if we put together in teams exactly like how humans work today? So at the top, we have a management agent, which is mostly talking to humans, gathering requirements, and so on. And then we have the engineering agents, which have specialized instruction, knowledge bases, and so on. And the last fundamental piece, which Synera has always been doing, was workflows. We want to equip the agents and this whole team with factual rule-based workflows so that whenever we give a requirement to this whole system, they come up with solutions that are more human-like and are actually feasible. And how do these work? So there are 4 steps to make these transition from a low-code workflows to building multi-agent systems. At first, we always start with building these low-code automations. So what we have a low-code platform with visualization capabilities, so you can capture all of your engineering knowledge and processes as they are today and put them into low-code. we have an open platform marketplace where you can connect any CAX tool within your organization into this low-code platform. And we have our partnerships with a lot of players and partners from across the industries, so making it easier for you to build these low-code workflows. And the third step is where it gets interesting, because Synera gives you the capability to take these low-code workflows and make them tools via API for these agents. And at the last, when you equip agents with these tools, they can perform autonomously like a multi-agent system. But Moritz, back to you. Do you want to show us how this actually looks like?
Yeah, absolutely. Ram, thanks for pointing out these 4 steps. Of course, we want to see this in action, right? So what I would like to show you next is a little Hello World example for the step 1, 2, and 3. And then we have prepared 2 demos for you for multi-agents on real use cases. And to have like a basic understanding on how we actually model the initial workflows, like the logics, and then actually connect tools and then publish it to a callable function or tool for agents, I would like to give you a little demo how this could look like. So what you're seeing here is actually our low-code development platform. On the right side, this is the 3D window where we have the geometry visualized. And on the left side, this is our digital canvas where we kind of like do the visual programming. And I want to show you a little Hello World example here, just 2 sliders, 2 numbers, 2 variables. And I want to multiply these 2 numbers. So it's classical mathematical operations in here. 5 times 8 is 40. And a node has always inputs on the left and outputs on the right. And if I change the sliders, actually the result downstream gets updated. So this is the idea of Synera in a nutshell. And we have lots of connectors. I guess it's over 2,000 at the moment off-the-shelf capabilities, like, for example, connecting to CATIA, or you want to connect to Excel, or you want to maybe go into some more math operations, logical operations, maybe similar to MATLAB. If this is larger than that, then leads to this. So classical rule-based automation. We also have like a full CAD system behind it. And that's what I want to show you here. So let's create a little sphere. And you see that the geometry is represented also now on the right side. And if I, for example, connect the result of the multiplication with the radius, I have created a very simple parametric CAD file in here. But now, for example, it could be the case that you actually want to, I don't know, maybe mesh the geometry for putting it for some finite element simulations. So you can either use, for example, our internal meshing capabilities. So you just need to define the element size. And now we get like the meshed representation. So this is basically off-the-shelf capabilities. But also, I guess, lots of you are using special software tools. And Ram already mentioned there are hundreds of tools in engineering. So we've created this kind of open system where you, for example, can just connect to your existing expert tools. In this case, I want to show you maybe Hypermesh from Altair as a good measure. We can do the same with our internal meshing, just connect the body and maybe the element size. And now what happens in the background is actually that we are remote controlling Altair software in our low-code workflow. So it's as simple as that. It's just like visual programming. And in a couple of seconds, once this meshing is done, you should see the results that Altair produced, and we can further process it. And I need to be sure like this mesh looks better than our internal one. So great job, Altair. But yeah, let's make it a little bit more simpler here for this demo. Let's just calculate the area of the sphere. And this is a single node. It's 2,800 square millimeters here. And I also can put this as a output in a container. So let's assume this is a very complex engineering workflow. Of course, this is Hello World example here, but it comes with inputs and outputs. So what we're gonna do here is we define those 2 items, A and B, as inputs. So this should be, for example, like something an agent should be able to control. And the output actually we define as well as the area. We can then select, okay, what's needed to be visualized. That's here. And that's it. So this, as simple as it gets, we define inputs and outputs of rule-based automations. In this case, the automation would be, well, calculate the area. We save it. And now the cool thing is with Synera, we can just publish this server to a server. In this case, it's like a cloud server. So you need to be logged in, single sign-on if possible. And then we can publish it. And what we get back now here is the human interface for this workflow, which is a website. So you can see on the left those sliders, on the right actually now the result of the area, and the middle the sphere. So this is basically the workflow, and it also comes, of course, with a link. that we might also be able to share with you here. And I would like to ask you, we put it here in the chat, the link, just to try it out on your own. Let's assume you are given the task to create or to calculate the, what is it, like the area of a sphere with the two input parameters. And yeah, maybe you can test this out on your own.
Yeah, we already got a question asked, and I just put the link also as a reply to this question. So,
Cool.
yeah.
So I hope everybody is able to access the website. If not, please raise us, and I will put it in the chat here again. And I guess you should be able to see it. Yeah, I guess it's working, hopefully. Yes, perfect. So this is actually the human interface that you can think about how we democratize actually knowledge. So of course, this was a Hello World example. What our customers are doing is way more complex. So think about, for example, you have a complex assembly in CAD and you want to know what is the eigenfrequencies or the load cases. So perhaps your FEA department has actually created like a nice workflow which calculates the stresses and displacements. And you are able to send this kind of website or this link to a colleague in the CAD department, the design department, which then can automatically create a stress report, which actually is quality approved. So the same thing, actually, like you do as humans, we can give these workflows to agents. Then, of course, not over a website, but with a REST API that is a callable function. So, Ram, how does this work actually? How do we work and let each other of these agents talk to each other?
Yeah, thanks for the demo, Moritz. So what Moritz showed right now was how to build a low-code workflow and publish as an API, but we still have to, let's say, instruct these LLMs to behave like engineering agents. And that's what we do next. Once we have our API-ready workflow, we first start with prompt engineering. And it might sound simple, but it's really the effective thing with LLMs that you can write a set of instructions, a set of tasks to do, and that the LLM has to obey, and also like a profile. What is this agent built for? And we prompt this and give it to an agent. It could be as simple as, hey, you're a CAD engineer, you're responsible for generating successful CAD models. And then what we need to do is take these API callable workflows built in Synera and pair these to agents. And now, whenever we ask an input to an agent, the agent can autonomously call these workflows, set inputs, get the actual output, and make answers out of it. And once we have one agent ready, it's the same for doing it for multiple agents. So we built all our multiple agents, we paired them together using a network, and then we have our own AI multi-agent system for engineering done. And then the question is actually, where do they come into play? This all sounds cool on paper, and that is what we want to talk about today. What are some interesting problems that these agents can solve together? And that is what we want to show you with one of our exciting projects we did with OEM. And that was actually to do an cost estimation and optimization for a door trim assembly. So when we first got this problem, we sat down together with a group of engineers and tried to understand how do they work today and what are the problems and what are the key challenges when they want to do cost estimation, for example, this door trim assembly. And we just started from there. We started to understand how do these human engineers work together, and we figured out that there is a system there. So there is always a cost manager who's responsible to talk to the actual CAD designer and do the costing. And we represent this with the cost manager agent. And then there is also the CAD expert agent. And this agent is responsible to call CAD workflows, take in input requirements, and generate CAD. There is also a second one, and this is also very interesting how we solve this problem. And this is a process agent. Usually there is an engineer who is also responsible for drafting the bill of process. And we figured out that LLMs can also act as these specific engineers. And therefore, we give it a specific workflow through which these agents can call based on the inputs and come up with the bill of process. And the last one is a costing specialist or costing analyst. So this agent receives input from all other agents. Once all the input information is available, it calls a scenario workflow that could be connected to a should costing tool. For example, we have our partners with Facton. It could just set inputs, get the cost out, and report back to the manager agent, who then gives the actual human engineer the answer, what this part could look like in terms of process, cost, and how can we optimize it. So we took that and we built an easy interface for these engineers to work with. And this is how it looks like. So it's a chat interface, very intuitive to everyone. On the left, we already see the graph that we just saw in the previous moment, and we can start already talking to the system. A first question could be simple, like, hey, how can you help me? And what's interesting now is on the right, we can actually see traces of who is talking to us and who is going to respond to us. And because this was a general question, it's only the engineering manager agent who's responding to us saying that I can analyze manufacturing cost, I can provide cost estimation, I can also give some manufacturing insights, and so on. And this agent also asks for some necessary input from us. Can you give me some specification of CAD and so on? So I give it an input. I say, I just point it to a step file that I want to figure out cost for. I also give a production volume. And now again, going back to the traces, we see the agents working together. So first, the engineering manager agent calls the next agent. It figures out that I need to call the CAD agent because I received a CAD input. And the CAD agent says, let me analyze the CAD that you gave me, and I will try to come up with an answer for this. And what happens now on the background is that this agent has called a scenario workflow, has set the input, and Sinara is actually importing the geometry and making sure all the outputs are available, and it comes back to the agent here. So we see that this tool has been called, we get the necessary files out, and now we see the interpretation from this CAD agent. It says, I have been able to analyze it and can observe the geometric features. I can now see I need to go to the next step. I would like to give it for the next agents who are better experts than me, and that is what happens. So next, the bill of process agent is called, and this agent is taking the output from previous agent and is now preparing itself to generate the bill of process. Again, calling a scenario workflow, getting the necessary inputs, and saving a bill of process. And it goes in the same fashion. Now we have a real factually driven interpretation and not a hallucination or an imaginative answer. We really have an answer that is based on ground truth. And with all this information, it goes to the cost analysis tool, and the cost analysis tools interprets all the information that came along, actually calls the scenario workflow, get the cost out. So as you can see, we have different cost outputs coming in. And based on this interpretation, the manager agent summarizes the whole scope of work. And in just under 3 minutes, we have a summary. We have a summary saying that the system of agents were able to analyze the input. They also give us a cost structure breakdown. They give us some process assessment. They also reveal information about what led to this information, and we see what was actually generated in one of the workflows, which is an exploded view, and how it interpreted. And when we first saw this, it was also mind-blowing to us how these agents work well together when you put the right tools in place. Now here is another interesting. I just asked it, are there any lower cost alternatives? So very indirect question, but it knows, the system knows that I need to call my cost manager agent and ask this agent what to do. And then we get recommendations. So maybe you can try to look for process alternatives. Maybe we should think about production volume or even about equipments. And it asks the human engineers, what would you like to do? How shall we proceed? So these systems are really thinking that they need to help the human engineers come up with answers faster. And that's what we see here. This only took 4 to 5 minutes in total to get to this point of clarity. And I think that's super interesting and mind-blowing what LLMs with the right orchestration and scenario workflows can do. And I guess we had some cool learnings here, Moritz, when we did this.
Absolutely. I mean, thanks, Ram, for the presentation here. My first question before we go to the key learnings was, what actually was your hardest nut to crack when we built up this workflow? So what was like the thing where you said, well, I'm actually not sure if an AI or large language model can really do this job, and where you have been like overwhelmed by the capabilities, or maybe also like missed expectations on the LLM side?
Yeah, I think what I was always thinking about was, can the LLM call the right tool and set the right input? Because these are really complex tasks. Can the information flow effectively between one agent to another?
Mhm.
And then we figured out, if you pass it as a JSON, for example, then these workflows can pick it up faster, and they can process it better. And LLMs are more easier to understand JSON rather than heavy text. So this was really a learning experience for me during this project. Also, it was mind-blowing that it was successful.
Right. Thanks for sharing this insight, Ram. So yeah, what are the key learnings actually for this use case for the door trim assembly? I guess one of the main highlights definitely is that LLMs are able to generate a bill of process based on a screenshot, basically. Like this is something which we didn't expect and where we actually see capabilities of the pre-trained models coming hand in hand with the engineering skills. And this is really something where we believe this hybrid system of rule-based engineering automation and artificial intelligence really plays off the benefits of both worlds. We also have the opportunity, for example, to connect to software tools. And in this example, especially to Facton, should costing, calculation. So we are actually knowing that these kind of agents do the right cost calculations because it's physically correct, and they are actually just like remote calling in this case, expert software tool like Facton. Also, what was interesting is if you have seen, the middle agent actually had this RAG database. We're calling this a retrieval augmented generation piece. So we are able to equip those agents with company knowledge. So this is something you have to think about, like a library where the agents can look up what, for example, manufacturing machines are inside of the company, or what kind of knowledge actually we are able to do. So this is really interesting because you can kind of like fine-tune the agents to really answer and act as they would have been employees inside of your company. And I guess the last learning definitely is that if the scenario workflows add tools for agents without, they may fail. So really, this is something where we add capabilities, engineering capabilities to these AI agents that really like brings this whole system, this multi-agent system to a new level, and also to be able to really kind of like act like real engineers. So if you want to deep dive a little bit more into this costing use case, I have also shared a QR code here with you. It's a recording of our last webinar, Discover Next Level Cost Engineering with CAD to Cost. There is even more demos in automation, in costing, and RFQ events. So if you are interested in this, feel free to scan the QR code or also look onto our website. There is also the links of the past webinars of the recordings. Maybe before we jump to the next start round, there's already some interesting questions which we can maybe answer in here. And there was one question actually, what kind of LLMs are you using? Maybe we can give a short answer to this one immediately.
Yeah, sure. So we are here using multimodal LLMs. So we are accessing this via, for example, in this case, it was AWS Bedrock, but also if you're using Azure or any other cloud provider, we can interface this to like a middle layer through which we can call the most effective LLMs. So that is how we did this here.
Perfect. I guess that's a good question. There's already some of more questions popping in, but I guess before we are jumping into all of this, let's keep them for the Q&A session maybe later because they don't fit right now. But there's one interesting learning which we also have done over the last couple of months. The question is always the case when it's the right time for agents. I mean, is it always good to use agents, or should we go for any other type of, for example, these surrogate models or use order models, or shall we just stick with rule-based automation, which also might do the job? So let me maybe share one learning that we have done in the last couple of months. Actually, we tried to separate these three types of automation a little bit more. So the sphere and how we build it up, this initial workflow, this is what we call rule-based automation. So we're doing this with our low-code platform. We wire up nodes, logics, deterministic and predefined tasks that we can automate for it. So this is especially helpful if there is a logic behind it. And it's super fast, it's super robust, it's easy to build. And a typical use case could be just import CATIA, mesh the part with 5 mm, and run a linear FEA simulation. So if you can do rule-based automation, that's the prior one goal for you because it's just easy, fast, and robust. Then there are cases, for example, where we're calling it AI-enhanced workflows. So where you have a rule-based deterministic workflow, and then you have one piece of the workflow where you need to have a large language model or a reduced order model, actually, because you somehow do not want to do this in a classical rule-based way. So it's kind of like a deterministic workflow, which still adds some flexibility or speeds up when the rule-based workflows are not capable of doing it anymore. So this could be done by more complex rules, for example, more fuzzy rules in here. But of course, also the weakness of this process is that the output of the AI needs to be machine readable, defined in a very concrete way so that actually the follow-on deterministic workflow can actually like process it. And I guess one of the best examples here are these reduced order models like stress prediction. So for example, if you are working with Navasto, for example, or NeuroConcept, this is the tools actually you want to go to when you want to have like, for example, a 8 hours long lasting CFD simulation. You want to run thousands of designs, historical data, then train and reduced order models, and then actually predict the stress results or the CFD draft coefficients within seconds. So we're calling this AI enhanced workflows. And then there's the third puzzle piece, and here we are talking about agentic automation. So agentic automation is really good to have this kind of intelligent, adaptive, let's say, behavior. I would call it even human-like behavior. So for example, if you have use cases where usually it's just like a stomach feeling, or you need to have a full study of expert knowledge actually to actually just say, well, I think this is the right thing, or you want to have some decision making or compromise finding where you don't have a clear rule how this works, then agentic system just add this kind of intelligence and adaptability in the system. And of course, the use cases are separately, lots of them. Maybe an initial very interesting thing is definitely RFQ processes, right? Because RFQ processes are so complicated. There's information coming in with 100 pages of documents of customer requirements. Somebody needs to analyze them. Somebody needs to actually put them over into engineer readable formats. You need to process multiple tools like CAD, simulation, costing. Then you need to argue. You need to find a strategy. So this is really something where, for example, real teams need to be involved. And also, this has a great potential to be automized because if you answer faster to our RFQ element, you get a really strategic value. You can just get the deal or you can like get the right price. And this really is for strategic value. And I guess with this being said, it would be great, Ram, if we could also maybe see an agentic demo of an RFQ use case. What do you think?
Yeah, absolutely. Thanks for distinguishing these different kind of automation because I think even in the AI world, everything is perceived in different ways, and having this clear distinction will also help everyone choose the right method. Maybe agentic is specific for certain kind of application, rule-based is best for certain kind of automation tasks and to be faster. But like you mentioned, Moritz, agentic is perfect for this kind of cross-domain, cross functional results, and that is what RFQ is all about. And perfect time to show what we did with RFQ here. And like Moritz mentioned, RFQ is a very special, super strategic, and important process for a lot of companies. And usually, what happens in this request for quotation processes, there is an input requirement coming, and it gets distributed to different teams who all have to work parallelly to come together for a first answer, talk with each other, refine this, and then send out a reply back to the quotation that came in. And again, this is what we tried to do. We sat down with a team that works for RFQ, and we try to understand how do they work today? What are the challenges? What are the processes? How do they communicate and so on? And we figured out an RFQ multi-agent system could look like this. So on the top, there is the RFQ manager, and this is the one who usually talks to the user, a human, tries to understand what are they actually looking for. And this agent then breaks down the unstructured or maybe even unspecific input into specific, really measurable and clear inputs for other agents. For example, the commodity agent or commodity analyst, this analyst can look at all the databases existing today, use a scenario workflow to maybe talk to PLM and understand what do we have today in-house. Once this agent gets the information, it can pass it to maybe an assembly agent who can then get the context. This is the project that we are looking for, and these are the options we have. So for example, it could be another one of those RAG databases that Moritz mentioned, through which this agent can look up what is the best way to do this assembly. And then this information about the component gets passed to a purchasing analyst, again, a different domain. But when we have the right workflows to connect to the tools involved in this process, this purchasing analyst agent can take in all the information, find out the best purchasing strategy, and then once with that information, the costing analyst can have a complete overview of what are the cost parameters to set. And anytime there is a CAD functionality missing or there is a important information that is required missing, the CAD engineer comes into this team, generates the CAD needed, and gives this information to the relevant agents. So they all work together as a team, try to answer as fast as possible to the incoming request from the human. And again, we build this system with actual workflows, and we put it here. So on the left, again, there is the interface that we are all used to when using LLMs. And you can see the graph. It's a bit bigger now. So there is a lot of tasks and a lot of scenario workflows underneath it, a lot of automations built for agents. And then on the right, we will see how these agents work together. But we can already start with asking one of our favorite questions. Hey, how can you help me? And we will already see which agent is the one going to respond now. And because this was a question, general question, it's just the manager agent. The manager agent represents the whole system and it says, we can do technical analysis, supply chain assessment, and cost analysis. And now we can give it the actual requirement. So we are building here a system for a filtration system. So that's why the requirement is we need a flow rate here, a pressure drop, and a mass. And we already see that the agents have started working together. So the first agent, the commodity agent, already retrieved a part that is closer here. And the CAD tool has been called to generate this CAD, maybe viewer screenshots, so that it can be passed to the next agent. And that is the assembly agent, which is now calling actual scenario workflows, passing this information and figuring out what is the best assembly type. And then this information gets passed to the purchasing agent. So in between all these steps, there is always a scenario workflow being called. There is a lot of information that is exchanged between these agents. And we see how the interpretation are really factually driven. And once all this pre-information has been obtained, we give it to the costing agent. The costing agent gets results back from the scenario workflow and determines this is what the best cost estimate. And under 5 minutes, we get our first answer already. So the system says, for this configuration, this could be the manufacturing approach. And we also get some supply chain details, which is a very important first guess in this process. And we also have what are the advantages when going to this way, this method. And it also says, how can we proceed? What are the best ways to proceed? And again, another interesting thing, what these systems are capable of. Many times we have very intuitive or simple questions like how does the cost change when my production volume changes? And now the system figures out that I don't have to call any other agent, but only the cost analysis agent because this is a costing related question. And this saves so much time because we don't have to redo the process again and again. The input directly goes to the relevant agent. The agent calls the necessary tools. It even runs 2 scenarios, gets the output, and compares what does it mean? What are the different cost parameters? And again, this is in less than 1.5 minutes, we get our answer to a kind of a tricky question. So it says, I compared it for 30 units and 10,000 units along with 7,000 units. So it remembers what was the previous output, what have I done now, and what does this mean for this engineering requirement. And yeah, it again gives us a more detailed overview and also the scenario generated CAD image that the user can take a look at. And I guess this was one of the most, let's say, useful leverages of how to make sure we put LLMs plus engineering workflows in the right use case. And I think, again, when we did this, we had a lot of interesting insights. We also got to know how much data is important. So no matter how much we have workflows or AI, it really boils down to data. And I guess, Moritz, we had a couple of other learnings from this whole project. So back to you to share more of these insights.
Absolutely. Thanks, Ram, for the second demo. And again, I would like to summarize basically the key learnings when we built up this RFQ agentic system. So first of all, I guess, actually, when you go rule-based automation, for example, for the CAD and the simulation, you ensure that the results are physically correct. And I guess this is one of the main learnings that we have done here. We get correct results. So for example, the prices, the lead times, this is not an LLM coming up with any kind of, let's say, not necessarily correct data. It's the rule-based physical grounded truth. And if you like take this into account, that it's the correct results with this interactive, let's say, working style of the agentic systems, we really think that the LLMs can somehow add this kind of strategic expert knowledge to classical automation. So there was also a question here in the chat actually where we maybe can answer this. So the question was actually, what is the difference compared to a direct connection of the workflows? Sure, I can use language to start it and get a text feedback. I guess, Marcel, this question might potentially be answered with a demo. So for example, the LLM can come up with strategies for supply chains or vendors. Should I go for single vendor strategy or multiple vendor strategy? Because this is just inside of the LLM. So it has been pre-trained. It knows basically strategies. If you have worked with ChatGPT, you kind of like get an idea what comes off the shelf of these LLMs. So we think about adding this additional intelligence layer to the rule-based engineering kind of gives you this dynamics or kind of like more intelligent system than just rule-based. And also what I really like to mention is here, I guess we talked about this at the very first slide, Ram, that each agent has a memory, but also like the agentic system in general has kind of like a system memory. And I think this is really important to know. So if you are interacting with the system more and more and more, it learns from every time actually it runs through. So in the background, we just store every kind of decision, so it gets smarter. So this is like a strategic advantage. The sooner you start using these systems, the more elaborated, the more efficient they get over time. And last but not least, actually, having the right data strategy in place is necessary. So we have learned it all starts down with the workflows. Without having your data prepared, without having actually your tools connected, these logics behind, this is the key to success to have value in these agentic systems. Because otherwise, they are just coming up with any kind of maybe not so true results. But if you combine this thing, if you get your data right, you connect your workflows, your tools, and then give it into the hand of agents, this is really, really powerful. And again here, a short reminder, we already did one of the webinars on this specifically topic of RFQ events, of processes, and how to automate them, how to, for example, automatically create a FEA report based on a new geometry if you do some engineering to order things. So if you're interested in this topic, I definitely would like to recommend watching the webinar. It's recorded, and this might be also something which you get some more informations. So before we actually come to the conclusion, I would like to raise another question here in the round. Now that you have seen actually those two demos and you also got like the idea of what is actually necessary, I would like to raise the questions. If you had AI agents right now in engineering, what would actually be the automation that you would like to automate first? So let me start the poll, the second one. And I hope, again, you get like the question. You can just answer free text in there this time. So what do you think is the most high potential or maybe also most annoying kind of thing that you would like to automate with AI agents in your R&D department? Okay, 3, 2, 1. All right, let's look into it. I guess I can also, I'm not sure actually if I can share it, but maybe I can. Um, so let's see if you have access or if you need to log in. I'm not sure actually. But definitely we will share the insights maybe in a second with you once I did the aftermath. And in the meantime, I would just like to yeah, give you a little idea on how actually we see the future with these AI agents coming into engineering. So at the moment, we mostly see this kind of manual engineering. So of course, there's rule-based automation. You have scripts, you have automations, but still it's humans talking to humans, sitting in meetings. And actually, if you want to accelerate stuff, you actually need to have more power in there, more people in there, or outsource more, buy more, or automate more. But in the near future, I guess what we can see today, and even this is super early today. I mean, ChatGPT is out for 2.5 years now. I'm not sure actually. So this is only the beginning. So imagine if these models get more capable and we can really connect them to our engineering tool stack. We really see this transition into an agent-aided R&D organization where engineers actually have the opportunity to work hand in hand with AI agents to maybe do all of the iterations before and then getting into more a decision-making mode or kind of like getting like a pre-written exercise on how maybe you should do this and this, and then we do the quality assessments. So the roles will change for sure for us. Exciting times, and I guess with this we can directly, let's say, end the official part and jump into some Q&A sessions. So feel free to raise your questions here in the F&A chat or Q&A chat, whether you have like an English or German Zoom in here. And we will just like put it out there and read through it. And so maybe the first question, Ram, comes from an anonymous question. Is an agent like a human, or do you train with your AI model?
Interesting one. I also saw a similar question. Is there a Synera inherent LLM? So we don't train any AI. So we don't take an LLM and train it for hours or so on. What we do is, for example, use, like I mentioned, AWS Bedrock, Amazon Bedrock. Amazon Bedrock already offers us easy way to connect to different kind of LLMs that are available inside an organization. We just connect to these agents. What really helps instruct these agents are prompts. So the quick answer is we don't have you don't need to build a super powerful LLM. We take the existing LLMs, add prompt engineering, and connect them to Synera tools or workflows to make this happen. So that's, I guess, answering the question.
Cool. Thank you very much, Ram. Um, Another question from Thomas here. Is an AI multi-agent system able to read PDFs, and is there a size limit?
Interesting. I mean, definitely any LLMs can read PDF if we use the right model. So there are some models which don't have ability to look through files. So we have to find out which model is best suitable for which kind of PDFs. And once this is available, let's say again in this middle platform like AWS Bedrock, we can just identify them and then use this LLM as the base LLM for Synera agent. So I think but it's definitely a good, let's say, task for an LLM that it reads through, I don't know, 40, 50, 60 pages of PDF to extract like a boundary condition or so on. So it's definitely valuable and goes in the right direction.
Yeah, thanks for answering. If there's any other questions open, just like remind ourselves if the answer was not fully like sufficient. Another question is super interesting, Ram. What about data security? So where is the brain stored? That's an interesting one, huh?
Yeah, that's an interesting one. Maybe I give my opinions, Moritz, and then you give
Yeah.
yours. So Synera is itself an on-premise platform. So every workflow, every data that goes into the workflow is on-premise. It is not on cloud. It is not on flying anywhere. We are fully on-premise platform. That means it's always inside this low-code environment. And when we connect a low-code workflow with an agent, it's only via API. So the agent or LLM doesn't actually, let's say, know what's happening inside the workflow or what is your, let's say, formula or how are you doing this. What an agent does is calls an workflow, it sets the input and gets back an output with the context we provided in the prompts. And this is, I think, a very elegant way to make sure there is no, let's say, we don't have to upload anything directly to LLMs, but also LLMs have the clarity that they need to make factual decisions. And added along with that, when we use platforms like AWS or Azure and other infrastructure, this makes sure that the whole IT and data security is already ensured. And I guess this is how Synera has always been focused on to make sure we don't, or that the data is really with the organization on premise.
Amazing. I mean, something to add, if you really also don't want to put anything out there to your LLM providers, right? You can even think about actually hosting your own LLM locally. I guess there are some providers that just allow this to you. Of course, you would need to have a huge computational power inside. But I guess if you want to do this, maybe if you are working in some areas where you don't want to have any kind of data getting out of your system, even not in your personal cloud infrastructure, this is feasible. This is also why we think these agents could be set up in any kind of way that actually fits your use case. Another interesting question from Benno actually is the CAT agent capabilities. Are they actually able to use advanced programs like CATIA or Creo in a meaningful way?
Absolutely. Again, going back to the low-code platform and our marketplace, so we have connections to major CAD tools. So we have something called Run CAD program. So if there is a parametric CAD part as a baseline, we can build a workflow in Synera that addresses or can manipulate these parameters and generate a CAD part. So for parametric CAD parts, we can build a low-code workflow and give it to agents. And what the agents have to do is set inputs and get the CAD back. And I think this is a very elegant way of making sure, that the parts are meaningful in a way.
Also step files?
For step files, I guess we need to go back to what can we parameterize from there? Is it more of a scaling approach? What kind of information we are looking for? So parametric CAD is always the best, especially like if it's a Creo file or a CATIA file, like asking the question, we can easily also help you to build these parametric files and link it to Synera using our partner marketplace, and then this should be possible.
Amazing. Thanks, Ram. So questions are popping in. I'm trying to scroll, so I guess we will not be able to answer all of them. But maybe let's find... Oh, this is a good one here. Do we have any tips on how to find the most appropriate tasks that are perfect to be solved by agents? This is something which actually drives us every day, finding the best use cases to start with. Maybe some learnings from you, Ram, so far.
Yeah, definitely. I think I can give a quick answer that there are three aspects to it. So we have to think about what are agents in general capable of, what can we automate, and what will be used by a lot of people in your team. So we can think through these three different dimensions. And then we know, for example, an LLM is very good at reading PDFs. And we have Synera, which can automate inputs, maybe create FEA models. And let's say there are a lot of engineers who anyway want to validate their designs. So what we do is democratization at a much larger scale and a more easier way. So even someone who doesn't know anything about FEA can talk to this tool and get an answer. Or it could be like an RFQ. We can equip a lot of departments with their own RFQ multi-agent systems with their own tools, and anyone who is available can talk to the system, get a first response. So yeah, thinking this is how I think I like to think: what are agents capable of, what is automation Synera capable of, and what will help a lot of people across an engineering organization. Maybe Moritz, you also have some from your experiences, some insights.
Yeah, so I guess one of the interesting aspects of starting with multi-agent systems is definitely, on the one hand, capabilities. That's actually what you focused on, Ram. But also on the other side, it's more on the business perspective. So if you find a use case which actually not only have the time-saving perspective, but more like a leverage, like if you save time, either you get like a better product and then you can save lots of costs in your production, or a strategic value, like you can fasten your time to market. This actually make these use cases way more interesting from a business perspective. And if you then also match this use case with the capabilities, with the kind of connections, then that's a sweet spot. So as a best guess at the moment, it's definitely all things around FEA automation. This is sweet spot democratization. We always heard from our customers, well, we have more CAD designers or construction team members than simulation experts. So this seems to be a common pattern to have these FE simulations experts as a bottleneck. So this is maybe a good starting point. But also, I guess if you're into 3D printing, this might be interesting. So lots of use cases possible in here. And there's also, if you go to the Scenario website, we have prepared a little like use case best practices there. Maybe we can share the link with you later, where you can get an inspiration on how to start and what the wins would be in there. So maybe before we go to the next question, I can give some insights about the answer that you guys did on what you actually would like to automate. And just reading through it, it's super interesting. So it's documentations, right? Annoying stuff. Nobody wants to read over 700 pages. Product certification. Oh yeah, I definitely know certification always kind of like is, yeah, stuff. It's cable routing here from the coffee companies. Very interesting. Costing, obviously. Quick dent and end identification. Oh, that's interesting. I've never heard about this. Maybe that's something I would like to deep dive in a little bit. It's control design guidelines, creation of drawings. Oh yeah, drawings, 2D drawings. Actually, I'm not sure if the models are already able to create or read drawings. Ram,
Yeah,
what is
yeah,
your
yeah,
experience
I'm
there?
every day trying, and they can read 2D drawings. I'm not sure about creating, but they can identify tolerances, standards, dimensions. Really interesting. And then we think about a scenario workflow, setting these inputs. Yeah, I'm already imagining things, but yeah, back to the insights.
Amazing. Maybe one last one is definitely cool. Automated reporting, like data to Word, PDF, PowerPoint. Annoying task if you need to do this over and over again, over iterations. So yeah, I guess you get the idea about what's possible, where we can save some time. And yeah, unfortunately, also we are running a little bit out of time, so there are still lots of questions left here. We will follow up with you in the aftermath, trying to answer this as a follow-up if you're interested in. And for today, I would just like to end maybe with a little next webinar announcement. So if you are interested in knowing more about agents in engineering and how they can actually like interact, we will actually break down the full topic in our next webinar. It's on the 20th of April, 4 p.m. So don't miss out on this one. Looking forward to get more discussions going and really going into this future, into this bright future where actually Jarvis maybe at some point will interact with us engineers. Ram, what do you think? Shall we call it a day?
Yeah, definitely. Thanks to everyone for the questions, and we'll make sure we get back to them. Uh, Absolutely a great round here, and looking forward to the conversations that will pop up.
Amazing. So thanks for stepping in today and have a great afternoon, everybody.
Thanks, everyone. Bye.